Hi, let's look at the Semester 2 Final Exam Review. To make the video not terribly long, we're going to focus on just the odd answers, starting with number 1. Factor the following polynomial expression, x cubed minus 125, into x plus a, x squared plus bx plus c. We have a formula that states, let's see where we are, that if I have, let me redo that, that if I have a cubed minus b cubed, then that result is going to be a minus b times a squared plus a times b plus b squared. So here I can see in this example that I have x cubed, so I have an x, something that's being cubed, that's like my a, x is my a, minus this is 5 cubed, so b is 5. So that's going to equal my a value is x minus my b value is 5. A squared is x squared plus a times b is 5 times x plus b squared is 5 squared. So in this example, x plus a, x plus a negative 5 plus bx plus 5x, b is 5, plus c, c is 25. So the value of a is 5, the value of b is, the value of a is negative 5, b is 5, and c is 25. Let's go look at, number 3. Oops, I went too far. Oh, sorry, number 8. So we're just going to do every other one. The numbering appears to be a little bit off. All right, let's look at number 8. Use the graph to the right to fill in the blanks. A function has a root of multiplicity of blank at x equals negative 1. So when I look at x equals negative 1, that's right here, I can see this line go straight through. There's no S curve that would make it cubic. It doesn't turn around, making it quadratic. So this means it's going through here at a linear pace. So that means it has a multiplicity of 1. At x equals 1, right here, we can also see that's going straight through. So that is also a multiplicity of 1. And at x equals negative 3, I can see that looks like the base of a parabola, like the vertex of a parabola. So that means it's a multiplicity of 2. Those are the only places we go through. And so this has a multiplicity of, or a degree of 1, 2, 3, 4. This is a 4th degree polynomial. All right, let's skip 10 and let's go to the next one. After 10, we're going to go to 21. Just pretend with me that the numbers make sense. Oh, it does make sense here. 11. 11. A polynomial has the following features. It has an odd degree, a single root at x equals 2, a 4th root at x equals 5. As x approaches positive infinity, f of x approaches negative infinity. So I know I have an odd degree, so my ends should be pointing when I graph it. My ends will go in opposite directions. So when I graph this one end will go up and the other one will go down. I know as we go towards positive infinity, my graph, my y value goes to negative infinity. So I know my graph is going to end up over here somewhere and it's going to go up over here somewhere. And it's going to do something in the middle. I know it's going to have a single root at x equals 2 and a 4th root at x equals negative 5. Okay, so I know here it's going to do a u value, and here it's going to go straight through. So we're going to look something like this, okay, where that's straight and that's a vertex looking. So as I go through this, since my graph is going downhill, I know it must have a negative coefficient. I don't know exactly what the coefficient might be without more information. So I'm just going to go with a -1. Without more information, I just know this is negative. And then I know I have my root, my fourth root is going to be this one here. So the one that's going to be raised to a fourth power is going through at a -5. So that means it's really x plus 5 raised to the, plus 5 raised to the fourth power. And then this one over here goes through at 2. So this is really going to be an x minus 2, and it's raised to the first power because it's a single root, which you don't have to write that 1 there. So A, we're going to go with -1. B, we're going to go with -2. C, we're going to go with a +5. And D, we have a +4. Let's skip down to number 13. For number 12 and 13, they are asking about polynomial division. You can either use long division or you can use synthetic division. I'm going to go with synthetic division. So when I have my 2x minus 3, if I were to solve that for 0, I would add 3 and divide by 2. So I would have 3/2. So 3/2 is what I'm going to be dividing by. My coefficients are 2, -3, -24, 76, and 60. And I have x to the 0, 1, 2, 3, and 4. So I'm not missing any. So I'm going to write them in order. 2, -3, -24, +76, and a -60. I'm going to bring my 2 down. 3/2 of 2, the 2's are going to cancel out, so that's just going to be 3. Which this is going to turn into 0. 3/2 of 0 is 0. 0 plus -24 is -24. 3/2, so if I divide that by 2, that is -12 times 3 is a -36, plus 76 is 40. Divided by 2 is 20, times 3 is 60. And this cancels to a remainder of 0. This is x to the 4th, so this becomes 2x to the 3rd plus 0x squared minus 24x plus 40. Now, because I have this denominator, I need to go in and I need to divide each of these by that denominator to get the correct coefficients. So I'm going to have 1x to the 3rd plus 0x squared, which normally we wouldn't have to write, but it's in here, so I'm going to keep it there so I know what its coefficient is, minus 12x plus 20. So I have x to the 3rd, I have 1, bx squared is 0x squared, cx is -12, and d is a +20. Okay? Let's go look at 18 and 19. Now the difference between 18 and 19 is one's varying directly and one's varying indirectly. So I do want to kind of point that out since we're only going to do one. So remember when you're doing direct vary, I should highlight directly. Undo. Directly and inversely. So those are going to be two separate equations that you're setting up. Direct variation is going to be set up using y equals k times x, and inverse is y equals k over x. Okay, so now that we have that out of the way, we can work this problem. All right, so the current varies inversely. So that means my y is c. The current varies inversely as the resistance of R. So that's how I'm setting up my equation. The current is 12, so C equals 12, when the resistance is 240. All right, so to solve this, what I'm going to do is I'm going to multiply both sides by 240. So 240 times 12, that's going to be 0, that's going to be 8, that's going to be 4. 0, 0, 4, 2, 8, 8, 2. So I have a 2880 as my value for K. Because on this side, when I multiplied by that 240 on both sides, this side it canceled, I just have K. So what is the constant of proportionality? It is 2880. So now when I write my equation, y equals 2880 over R. What is the current when the resistance is 480? So what is the current when the resistance is 480? So let's see. I'm going to reduce this fraction. These are both divisible by at least 2. So that's going to be 144 over 24. Those are both divisible by 12. That's going to be 12 over 2, which is 6. Okay? So the current is going to be 6. All right, number 21 is working with graphing. So make sure on number 21 that you're able to break down the different parts of the graph and fill in the equations for those. So for example, I know we're just doing every other one, but just so we can see this, let me make it smaller so I can see the graph and this at the same time. If x is less than or equal to -3, so that's going to be this portion of the graph, right? It wants to know what is the x minus 3 of this linear equation. What is the slope, right? mx plus b. So I know if I were to extend this, it would cross at a -3 down here because that's my b value. But what's the slope, right? So if I pick 2 points on here, I go down 1, 2, 3, 4, 5, 6 over 2. So my slope, and I'm going downhill, so it's negative. So my slope here is a -3. 1, 2, 3 over 1. 1, 2, 3 over 1, or 1, 2, 3 back 1. 1, 2, 3 back 1. We can see that is the slope. So A is -3. And so that's what it wants you to do in each of these sections. Figure out what we have going on. So for example, in the next one, we have, if I move to my absolute value function, I know normally it looks like this, right? But it has been slid over to the right 2 and down 2. So if it's gone over to the right 2, that means we subtract 2 from the x, and down 2, we subtract 2 from the whole thing. So B is 2 and C is 2 because the negatives are already in the equation. And remember the A was -3. And then for this last one, they just want to know if you were to keep going with this, where is it going to intercept? Oops. Where is it going to intercept that y-axis? Okay. All right, the next one. Now let's look at 22. So for 22, given the graph of f of x below, evaluate. So f of -6, 1, 2, 3, 4, 5, 6 is going to be a y value of -2. F of -3, so I have 2 places, but we want the solid value, so that's going to be 0. F of -1 is right here, which is 4. And f of 1, there are 2 values, but we want the solid dot, so that's going to be 1, 2, and 3 as my value. All right, 23, I know we're only doing every other one, but this goes really quick. If I have an R value was, I think there's a negative there. It's hard to, this probably goes with this number, negative 0.2401. 0.2 is a really low R value. So this is very weak, and I would go with there is no correlation there. Even though there's a negative symbol in front, that data is going to look real scattered. Like there's not really going to be much of a trend to that data. Okay, 24, here we have a R value that is very close to positive 1. So that's going to be a strong linear fit, and it's positive. So that data is going to look something more like that. And then 26, we have an R value of negative almost 1. So that's also going to be a pretty strong value, but this time it's going to be going downhill, so it's going to be a negative correlation. Okay? All right. And we were doing every other one, which should have put us here, but those were real quick, so I just did all of them. So now we're going to do this number 1. Okay? So which of the following equations is graphed below? When I look at this graph, I can see that I have a vertical asymptote at x equals 5. That means in the denominator, I should be looking for x minus 5, where I have, if I put a 5 in there, I get a 0 in the denominator because you can't divide by 0. So that makes me have an asymptote. So I need an x minus 5 in the denominator, which means I can rule this one out and I can roll this one out. The next thing I notice is I have a hole right here. That makes it easy to look at. I have a hole right here at 2. That means I should have an x minus 2 canceling out. So I should have an x minus 2 in the numerator and the denominator that cancels out. So that means, without looking at anything else, this would have to be my answer. Okay. The other thing I could check to get that x plus 1, right? My x-intercept will help me find that. My x-intercept is x equals negative 1, which means I should be looking for an x plus 1 in the numerator, which I see right there. So this one is my correct answer. All right, let's skip 42. Man, this numbering. And let's go to 32. All right, so considering this function, where do we have a vertical asymptote? Remember, your vertical asymptote is going to happen where you have a 0 in the denominator. So when 4x minus 8 equals 0. So I'm going to add 8 on both sides. 4x equals positive 8. I'm going to divide by 4. When x equals 2, I'm going to have a vertical asymptote. For my horizontal asymptote, we compare degrees. Okay, we're going to compare degrees. This has a degree of 1 and this has a degree of 1. So if they have the same degree, then we use the coefficients. So I have a coefficient of 1 over a coefficient of 4, so 1/4. Okay, and then when does the whole equation equal 0? The whole equation equals 0 if the numerator equals 0. So x minus 6 equals 0 when x equals a positive 6. Okay, all right, let's skip number 33 and go to 41. What are the values missing? What are the values missing the solution process? I think I'm missing the word in. The solution process of solving the following radical equation. Okay, so I can see here I have the same thing except I got rid of this minus 8 on this side, which means I must have added 8 on both sides so that this cancels out, and so that a value is going to be a positive 5. Then it wants us to continue solving and find our final solution. So we are at the square root of 5x minus 5. I'm not sure where my values are going. Okay, I think I got them back. Square root of 5x minus 5 equals 5. Oops, drop. Equals 5. All right, to get rid of this square, or square root, I need to square both sides. That's going to give me 5x minus 5 equals 25. Add 5 to both sides. Divide by 5, and x equals 6. All right, continuing on, let's skip number 41 and go to 46. All right, so here we can see we are multiplying. I'm going to take each section of my fractions and factor them. So 2x squared minus 3x minus 9. So I'm going to multiply my a times my c. That's a negative 18. And when I look at the factors of 18, and I'm looking to get a negative 3 in the middle when I subtract. So I'm going to do plus 3 and negative 6. So 2x squared plus 3x minus 6x minus 9. I'm going to factor by grouping. That's going to give me x times 2x plus 3. I want this to also be 2x plus 3, so I'm going to factor out a negative 3, which is going to give me 2x plus 3. So I'm going to have x minus 3, 2x plus 3. X minus 3, 2x plus 3. All right, then I'm going to factor this one here. This one's a little bit simpler because I have a 1 in front, so I can use the method where I just need to multiply to 10 and add to a negative 7 instead of having to factor by grouping. So I'm going to say probably 5 and 2, where if I want to get a positive here, they both have to be negative, so I can get a negative 7. All right, and then this one here, same thing. Since I have a 1x squared, I can do without factor by grouping. I know I'm going to have an x here and an x here. And negative 10, I think it's still going to be 5 and 2, but one's negative, one's positive. The 5 is going to be negative, so I get a negative 3. All right, here I'm going to have to factor this last one by grouping. 2 times 6 is 12. My multiples of 12 are 1 and 12. 2 and 6 and 4 and 3. I want to get a positive 7, so I'm going to do plus 4 plus 3 to get my positive 12 and my positive 7. So 2x squared plus 4x plus 3x plus 6. Factor by grouping. 2x, x plus 2. I want to get an x plus 2. I'm going to factor 3 out. X plus 2. So I'm going to have 2x plus 3 and x plus 2. 2x plus 3 and x plus 2. All right, since we are multiplying, I can keep it exactly as I see it here. On this one down here where I'm dividing, I'm going to have to take these second two and flip them, right? These would go on top, these would go on the bottom when I'm dividing. But here I'm multiplying. So I can go straight to canceling out. So x minus 3 doesn't cancel. 2x plus 3, that cancels right there. X minus 5 cancels. X plus 2 cancels. So I'm left with an x minus 3 in the numerator and an x minus 2 in the denominator. So this is x plus p. Oops, this is a minus 2. All right, x plus p plus a negative 3, and x plus q plus a minus 2. All right, let's skip 47 and go down to number 54. Okay, so for number 54, let's break this down. I'm going to have in my numerator 32x to the 4th, y to the 3rd, z to the negative 6. In my denominator, each thing is being squared. So 4 times 4 is 16. X to the second, or x squared squared is x to the 2 times 2. Y to the negative 2 to the 2 is y to the negative 4. We're multiplying. And negative 2 times 2 is z to the negative 4. Now, we take our coefficients and we divide them. That's going to be 2. And then we take our degrees and we subtract them. So that's going to be x to the 4 minus 4, y to the 3 minus a negative 4, and z to the negative 6 minus a negative 4. That's going to be 2x to the 0, which we wouldn't really have to write, but it's in here, so I'm going to write it. 3 to the, this turns into a plus, so that's going to be 7, y to the 7th. And z to the, this turns into a plus, so that is negative 2, which is 2x to the 0, y to the 7th, and then to make that a positive, we would move it to the denominator to make it positive. So my a value is 2, my lowercase b is 0, my c value on y is 7, and my d value on z is 2. All right, let's skip 55 and go to 56. Solve the equation below for x. So if I take this and I turn it into an exponential problem, I know that the base to the answer, oops, the base is 5. I don't have to put a b. The base to the answer equals the argument. So 5 times 5 times 5 is 125. All right, let's skip 57 and go to 58. Given the parent function y equals a times b to the x, sketch the graph of y equals negative 2x minus plus 3 plus 1. All right, so the 2 is going to be part of like a constant in this, right? That's my b value, so I'm not going to worry about that 2. What I'm going to worry about is this negative out in front. I know that's going to reflect over the x-axis. So that's going to take this and move it here. That's going to take this and move it here. And I'm still going to have my horizontal asymptote right here. It's going to look something like this, and that's just from that little piece that I just talked about. Then when I add this 3, that's going to move me left 3. So this is going to go 1, 2, 3. This is going to go 1, 2, 3. My horizontal asymptote's still going to stay there, so now we're going to look something like this. And then last but not least, this plus 1 is going to move the whole graph up 1. So my horizontal asymptote is now going to move here. And then this is going to move up 1. Oh, this one is going to move up 1. And this one is going to move up 1. So my final graph, I'm going to make it thicker. This is my horizontal asymptote. Oops, pretend that's dotted. And then my graph is going to look something like this. This is going to be my value for y. Put that back to a thin one. Okay. I know we're only doing every other one, but I do want to discuss this negative in this one just in case you see that on your final. Remember, when you have a negative like this, you have to factor it out of that. So we're really going to think of this as y equals 2 to the negative x minus 3 plus 2. And so that negative in with the x is going to reflect us across the y-axis, and then we're going to move right 2 and up 2, or right 3 and up 2. Okay? All right, let's look at 42. The domain and range for the function. So I'm going to graph our parent log base 10 Remember, your log has an asymptote on the y-axis. It goes through 1 right there. So this is my parent function. Okay, and I can see all I'm doing here is just x minus 2, so that means I'm moving the whole thing right 2. So that means my vertical asymptote is moving right here. And my graph is going to now look like this. So this blue graph is the one I'm working with. So my domain is going to be everything to the right of this vertical asymptote. So that's going to be at 2. So my domain is x values greater than 2. It might be written 2 to infinity. And then my y values, this kind of looks like it maybe approaches, but it keeps going up and up and up. So it is all real numbers. Or if it's like this, we're going to have negative infinity to positive infinity. All the way down, all the way, that's going to keep going up and up and up. Okay, this one's going to be the same type of process. We're going to be moving left 4. It's the same shape of graph. Okay. Let's look at 43, our last problem. So 4 to the x equals 52 can be estimated without a calculator. I know that 4 to the first is 4. 4 squared is 16, and 4 cubed is 64. So 52 falls in between 16 and 64, so that means it is between 2 and 3. Okay, to solve this, I know that when I have a log with a base, let me change colors. I didn't change colors. When I have a log with a base of an argument, it's going to give me an answer. This can be changed into an exponential equation by saying the base to the answer equals the argument. Okay, so I can see that here I have my base is 4, my answer is x, and my argument is 52. So when I look here, my base is 4, my argument is 52, my answer is x. Okay, so here I'm going to have, if I rewrite this, I'm going to have log base 4 of 52 equals the answer. So my log is base 4, my log is base 4, and my answer is 52. So A is my argument, that is 52, and my base is 4. Okay, hopefully this helps you out. If not, I do have Tutoring Tuesday today after school. You are more than welcome to stop by, and you can also look at the other answers. Thanks for watching.